Hello, very good evening, my friends. I'm Ashisom here from Learnbay, and today we are going to discuss, or we're going to talk about artificial intelligence. So we will discuss what artificial intelligence is and how it is related to data science or machine learning. If there is any difference, then what is that? This is the question that we have, many times. We get confused. Are they same, or is there any difference? If it is so, then what is that? So I'll be clarifying all such doubts. In between, if you have any, then you can share in the comment box and I'll get back to you. So let's start, my friends. First of all, if I go by definition, what is artificial intelligence? So it is the simulation of human intelligence to the machines. When we make the machines to behave like human beings, it is nothing but artificial intelligence. It is like we are imparting some human intelligence to machines and they act like machines. So very good example of that is the robots. So sometimes the robots they behave like human beings. They can answer some questions. They can suggest a few things like that. Chatbots are also in are very common nowadays when we call any call center or let's say to any airline and we call so chatbot is receiving the call and they start speaking like whether we want to talk about the tickets, we want to cancel our flight, something like that. So whenever some machine is working, computer system is responding with the minimal human intervention, then we call it as the artificial intelligence. Let me give you a few examples. So chatbot is there, as I was talking, like call assistants are there. Autonomous vehicles. So Tesla car is one of the examples. So autonomous vehicles which do not require any driver, they actually work upon the image processing or the image recognition, and they can automatically detect where to turn and where to stop and at what speed we have to go for. So that is one another example of artificial intelligence. Autonomous drones. So drones are generally, they fly without any human. And nowadays, remote handler is not required to, take care of the drones. They can automatically decide, once the path is decided, then they can automatically take decisions about everything. Now the robotics, that is another example of artificial intelligence I have been just talking about. Now, what I feel these very basic things that we all know, like when we talk about robotics and driverless cars and all, now it is artificial intelligence, right? But the thing is how it works and what is the basis to artificial intelligence. Then nowadays, many times we hear the terminology, let's say machine learning, then what machine learning is and what is the difference. So we will be talking about that and I will let you know how chatbots are working and how autonomous vehicles are working. What is the basic, idea behind this is working, my friends. So let's jump onto it. First, we discuss the types of artificial intelligence. There are three types of artificial intelligence. Once we call it as the narrow AI or weak AI. The another one is the general AI or strong AI also we call it. Sometimes it is also called AGI, artificial general intelligence. And the third one is the artificial super intelligence. Now, these all are the part of artificial intelligence. Let's discuss them one by one, and then I will be letting you know how they work. Initially, like what is the basis to all these technologies that we are talking about. First of all, the narrow AI. Now, narrow AI is the example that we call it as the weak AI, where some limited operation we can perform using AI. It is not have the it is something that doesn't have the complete intelligence of its own. Up to some limitations, it can perform some work with very minimal human interaction. That is the example of narrow AI. So if we talk about the examples nowadays related to narrow AI, those are virtual assistants. When we call someone and the virtual assistant is receiving the call and they say press one for this, press two for that, and whether you are looking for the booking for the tickets or the cancellation, you are looking for whether you want to change the date, something like this. Now, The examples of virtual assistants are also, Siri, Alexa, Google Assistants. These are also the examples. So we can talk to them. They can mimic up to some extent like human beings, and it looks like they know a lot. They behave like a human being, but is still their scope of working is very limited. Apart, no, more than that, they cannot do. They will not have their own intelligence completely. Up to some extent, only they are going to have. Chatbots are there, recommendation systems are there. So generally, recommendation systems they work with the OTT platforms or the online shopping portals that we have or the food delivery companies that we have. So let me give a very basic example related to the recommendation system. Let's say we go to the YouTube homepage and I search for any particular video. Let's say I search for some comedy stuff. So next time when I go to homepage, I will see a lot of recommended videos related to comedy. If somebody is interested in history, they will see like a lot of history related recommended videos are there on the homepage like that. Now, OTT platforms, they do it a lot depending upon the nature or the taste of a particular user. So they will suggest you if somebody, loves, let's say, the horror movies. So they will see a lot of horror related stuff on the homepage. If somebody is interested in comedy stuff, so they will see a lot of comedy related movies and it will give you like how much percent it is related. Let's say 90%, 70%, 65% match is there. So this is being done with the help of the recommendation systems. So this is one another example of the narrow AI. So their scope is again limited. They cannot do anything else apart from recommending for that particular platform. If you talk about the uh, let's say food delivering app nowadays that we have, so they keep on knocking and every now and then they ping in phone and let's say, would you like to have some specific dish, whether you have taken your breakfast or not. So they know your routine actually. Some algorithm is working internally that I'll be talking about. So in that algorithm knows, the user's routine, what time he eats, what time, what kind of food he prefers, whether he likes, what kind of dishes he likes, whether he likes spicy food or the less spicy food. And according to that, it is making some recommendation like, would you like to try pizza today? Or some new delicacy has been introduced by some particular restaurant that might be your favorite restaurant and it is suggesting from there. So chances are there you will say yes to that. Okay, okay, no problem. Let's have a try, and that is the business to the companies. So this is how it works. So these are a few examples of the recommendation systems. Image recognition, and this is a very useful, I would say, the case of narrow AI. So if you talk about Tesla or the autonomous vehicles, they work upon the image recognition. Now it is image recognition is being used in the healthcare sector also. It helps the radiologist detect a particular disease, especially with the help of the X-rays and the sonography images that we have. We can analyze them, and it helps the doctors, reach the diagnosis whether somebody has a particular disease or not. So image recognition has, that role also. Nowadays, many companies they use the image recognition to understand the behavior of the customers. Nowadays, you see the CCTV cameras are put everywhere in the malls, in the departmental stores. So let's say Walmart, if I take example. So they observe with the help of the CCTV cameras, they capture the images and then they try to understand the behavior of the customer. Like once they touch any product in the that is there in a rack, then how they behave, what are their facial expressions, whether they are focusing more on the ingredients or they just look at the price tag and then they keep it back or they keep it in the tray like that. So this is one other example of the image recognition. It is being used in healthcare a lot for autonomous vehicles and to understand the consumer behavior. So these are a few examples of the of the narrow AI. So face recognition in image recognition, we have Apple phone or many laptops. They open when when a particular person exposes his or her face towards the screen. So their image recognition algorithm is working. Autonomous vehicles I have already talked about that works upon the how they work. Let's say uh, every fraction of second or even less, maybe in every nanosecond, they captures thousands and thousands of images. Very high definition cameras are there. And on the basis of that, they analyze the distance for of a particular object, the size of the particular object, and then they decide their speed, whether the vehicle has to take brakes or not. On the basis of the image, they analyze whether they have to turn right or left and how steep turn they have to take, like this. Autonomous drones, they are also working upon the image recognition, same as the autonomous vehicles. Now, Google Maps. So, Google Maps is one more example of the narrow AI. They can suggest as the optimal path from the, you can say, the source to the destination. There might be n number of paths, but depending upon the traffic for a particular time, depending upon the, you can say, the roads or the paths to that particular destination, they can suggest the optimal path and along with the timings. So they are telling us the timings on the basis of images that are being taken by the satellites. The second example of artificial intelligence, that is general AI. In general AI, it is the replica of human being. When we create any machine, a machine that is that is mimicking the human being completely, let's say a humanoid kind of thing, or you can say we can sometimes we use those terminologies in the sci-fi movies and all, where we say, let's say, some clone has been created, or some robot or autobot we call sometimes, humanoid we call sometimes. They have the skin like human beings. Internally, they are machines, but we cannot judge like whether it's a machine or as a human being. And they can do everything a human being can do. So that part comes under general AI, though it is not possible yet. But it is said, let's say, Mr. Elon Musk has recently said it might be into picture by 2040. So we may see some, related kind of things in the coming time. But for now, it is just a hypothetical thing, we can say, only limited to movies, especially the sci-fi movies. But in reality, we don't have general AI into picture. But it may come in the coming time. The research and all is being, that is going on in this particular part. The last part of the artificial intelligence that we have, we call it the artificial super intelligence. It is the kind of intelligence that we impart to the machines where the machines surpass, the human beings. They are better than the human beings. So we are human beings, we are the biological creatures, we have our own limitations. So once the machines, of course, the physically they are, better than us, they are going to be more, they are going to be stronger than us. So if they have more intelligence than we have, then that kind of artificial intelligence is call it as the artificial super intelligence. So if I remember, the Terminator is a movie. We can say like we could see the use of such kind of artificial intelligence. It is a hypothetical thing. So far, it is not into picture. Tomorrow it may happen, it may not happen. We cannot say. But yes, the speculations are there. The researchers, they say it may happen in the coming time, but if it happens, that will be a threat to the whole, we can say, the human race. So we have to find a way. If it happens, then what we have to do? So we have to take preventive measures related to this. So for now, this is just a segregation of artificial intelligence, but practically it is not there. It is just a hypothetical thing. So we have seen what is artificial intelligence. So if I say in very basic thing, whenever we have some machine, we impart some knowledge to the machine. It is able to take decisions on its own without any human intervention up to some extent. And that is nothing but artificial intelligence, we call it. Now, how it happens, that is the next question. So for that, we have to understand the next part, and that we call it as the machine learning. So let's discuss artificial intelligence versus machine learning. Now, if I talk about the broader picture, artificial intelligence is the high level classification of the whole thing. Then machine learning is the sub part of artificial intelligence. And then one more part of machine learning, we call it as the deep learning or unsupervised learning. So this is the whole phenomenon related to artificial intelligence. We have artificial intelligence, we have machine learning, and we have deep learning. Now we will see how machine learning and deep learning are associated to artificial intelligence, and then if there is any difference, then what difference it is there. Let's first understand what machine learning is, and then we will be able to understand the difference. Now, machine learning is, we call it as the subset of artificial intelligence. And in this, especially, we play with the algorithms. Those algorithms are the statistical models. Using those algorithms, we get the predictions like what may happen in future, how a particular person may behave like that. So what is the job of those algorithms? We feed the data to those algorithms, and their job is to learn the pattern or from the data. And on the basis of that learning, they start telling us, okay, this is how the particular person may behave, or this is how the prediction is going to be. Let me give you one example related to that. So generally, what happens? We have the data like this. In the tabular format, we have name, we have age, we have income, so it may be anything. And we have, let's say, gender of a person. We know the locality like this. And then we say, let's say this is our customer or not, whether this particular person is a buyer or not. So instead of customer, let's say I say buyer. And then we have some details here, and then we say this buyer is yes, then we have some details, then this particular say person is saying no, then we have some details, and then some particular person is saying yes, like this. So this is the tabular data, and this is the historical data that a company has collected, let's say, over a period of time. Now they have, got these details like the name, age, this these attributes they have recorded, and they know like whether that person bought the product or not the product. Now they want to create some automated model that can tell, let's say, if we feed these values, let's say name, age, income, gender, locality, whether that model can tell us whether somebody is going to be a buyer or not. So here we use the, this is the use of machine learning. What we actually do, we feed these, data row by row to some machine learning algorithm, and then algorithm tries to understand why this person is saying to be yes, why this person is saying to be no, like this. So whatever the data values we have here, what is the mathematical relationship is working here? That is the job of machine learning algorithm. Let me make it simple. Let's say I have some variable x and the result is y. So if I change in x, how my y is changing, if I know that relationship. So tomorrow if new value of x I get, I will tell like what will be the value of y. So this is nothing but very basic mathematical relationship. To identify this relationship is the job of a machine learning algorithm. So we say fx equal to y, something like this. This is we say in the form of mathematics. So what is the function of x that can give me the result y? To identify that function is the job of machine learning algorithm. And how it learns? We feed the data row by row and we tell the result. One row, one result, second row, second result, third row, third result. And that algorithm is nothing but a statistical model. Internally, it uses statistical techniques, and on the basis of that, it learns why this person is saying yes, why this person is saying no, and it represents that in the form of some mathematical relationship. It creates a mathematical function. Once we know this function, we feed the data of, we feed the value of x to the function, and it gives us the result y. Let's say this person is going to be yes, or this person is going to be no. So this is how it works. So algorithm is nothing but a mathematical function that learns the pattern from the data. After learning, it starts giving us the prediction. We can use it to know the behavior, to make conclusion, to do the forecasting and all. So there are a few examples of machine learning that we will see. Machine learning is again divided into two parts. The first is the supervised learning, and the second we call it as the unsupervised learning. Unsupervised learning is also known as the deep learning. Now, the example that I have just taken is the example of supervised learning. Supervised learning, we can say these are the features or the attributes, and here this is the result. Sometimes we call it as the target value. When result is given, we are telling the result also to the algorithm. Every time we are saying, if these are the values, this is the result. If these are the values, this is the result. If these are the values, this is the result. And you learn it. It is the example of supervised learning. It means we are supervising the algorithm here. Like if these are the values, this is the result. If these are the values, this is the result. With every set of, with every row, we are guiding the algorithm with the target value or with the result. That makes it the supervised, this is the example of supervised learning. The another learning that we have is the unsupervised learning or the deep learning. If this target column is not there, or we don't have the result, we don't know what the result is, we don't have anything to guide the algorithm, we don't have anything to supervise the algorithm, then it becomes the example of unsupervised learning. In that case, let's say I have the different data attributes, and the attributes are like this. I don't know what is their mathematical interpretation. I don't know anything. The data is like this. Now, deep learning algorithm, what it will do, in deep learning, it tries to understand the behavior of the different data points, and it will start segregating them. So it will be something like this. All stars, they have the similar behavior. They will come at one place. Then all triangles, they have similar kind of features. So they will come at one place. All circles, they have similar kind of behavior features, they will come at one place. So this is the example of unsupervised learning. When we don't have the target column present, when we don't have the result column present, this is the example of unsupervised learning or the deep learning. Now let's understand what are the use cases of machine learning and deep learning, and what kind of problems we can solve using machine learning and deep learning, my friends. So using supervised learning, we can tackle the problems where we have to predict some specific number. That number might be anything, where we may have to predict some specific category. Then we can use the supervised learning algorithm. So we use it for the predictive analysis. In predictive analytics, we can predict how much loan has to be reimbursed to particular person, how many employees we may require in the coming fiscal year, what would be the price of a particular stroke, how much market share we can expect in the coming year, like this, how much profit we can expect, how much additional capital is required to go into the diversified business. So all these are the examples of the predictive analytics, where we have to predict a value, whatever price product, okay, price of the product, cost of a particular firm or the business that we are going to start. So here some value we have to predict. It is the example of predictive analytics. The second we use in the healthcare diagnostics. In healthcare, if I talk about the examples related to supervised learning, so it may help whether some person is prone to a particular disease or is not prone to a particular disease, or we can get in the form of probability, like what are the chances that a particular person may have some specific disease after a certain age, depending upon their genetics, depending upon their lifestyles, depending upon their um, locality they are living, or if they already have some health issues. So keeping all those attributes in mind, we can tell, like, the probability, what is the probability for that particular person that they may have a certain disease or they may not have a certain disease after a certain age. Financial forecasting, let's say I want to invest, I am an investor and I want to invest, and many portfolios are available to choose from. So whether I should invest in equity, whether I should go with mutual funds, whether I should invest in stocks, or I should invest in property, then I may be knowing, I want to know, maybe like after 3 years or 5 years, how much return I may expect. If I go with mutual funds, how much I may expect after 3 years. If I invest in property, how much return I may expect after 3 years, like that. So we can create a predictive model using the supervised learning algorithms, and they can tell us, depending upon the current situation and the past records, how much return I may expect in different portfolios after a certain period of time. And accordingly, I can choose, okay, this is the best, domain where I can invest actually, like this. Fraud detection is widely used nowadays, especially with the financial firms and the banking firms. They use it. So some customer, if whether they will pay the debt or not, or it is going to be a let's say fraud, that is one aspect that we can deal with. It's a kind of yes or no situation, whether somebody is going to be yes or somebody is going to be no. In some cases, we can, let's say, thousands or millions and millions of transactions are taking place, and we want to say whether a particular time, we cannot um, run behind of all the transactions and we see whether they are legit or not. So we can create a model that can tell us, okay, these are the transactions that might be fraudulent, and we can have a check on that. So there are checks that we can put. So depending upon their frequency, depending upon their time they are taking, depending upon the iterations they are doing, to perform some particular transaction, we can decide, our model can decide whether this is a fraudulent transaction or not, or up to what extent, what is the probability like it may be a fraudulent transaction. So we can have a check on such transactions. So these were the few examples of the supervised learning algorithms. Now, as we have known now like what is unsupervised learning. Unsupervised learning or the deep learning, where we don't have the result column available or the target column available to supervise the algorithm. Like, okay, if these are the value, this would be the result. We don't have such a scenario. That problem becomes the unsupervised learning problem or the deep learning problem. So using deep learning algorithms, we actually solve the complex problems, or when the size of the data is huge and some complex relationship we have to find out. So we use the deep learning algorithms. So actually in deep learning algorithms, we work with the neural networks, artificial neural networks. Neural networks is the name of the algorithm that is the replica of human brain. As our brain, we have neurons. The cells of brain are known as neurons, and they work upon the impulses, right? So keeping that in mind, the name neural network has been given to it. It works the same way as human brain does. It is it is a mimic to the human brain, we can see. So as our brain works, the same way this works. Our brain works through the impulses. Then the same way we pass the impulses through some network, and it makes the decision upon based upon that. So that is the example of unsupervised learning. So when we start working with neural networks, it is nothing but unsupervised learning or deep learning. Using that, we can solve the complex problems which we cannot identify, for which we cannot identify a mathematical function, let's say fx equal to y. I am not able to draw that relationship. So we can use some deep learning algorithm, and that deep learning algorithm will find out that complex relationship that my normal algorithm is not able to find. So let's discuss the use cases of deep learning. Now, deep learning is widely used in image recognition and classification. So, image processing is the part of deep learning where we feed the different images to some deep learning algorithm, and it starts analyzing that, like where the difference is there, like some particular image that is very different from rest of the others, and it will make a point there, like this particular part is very different in a human body, in the rest of the previous images, like that, and we can decide whether there are some abnormalities or not. Natural language processing, we call it as NLP, that is mainly used for the text analysis, sentiment analysis we do. Nowadays, if we see, uh, mostly companies, they have their, social media pages, they have their own websites, and the reviews are there. They have their, YouTube pages, they have their LinkedIn pages, and anywhere the, customers can give feedback to them. They can write something about the products in the comment box or in the review section. Now, lakhs and lakhs or millions of millions reviews are, and the comments are there sometimes. And the companies, it is not possible to manually go through them, but the company wants to know whether what the people are talking about, whether they are satisfied with their services or the products or not. So we can create a model using natural language processing. There actually internally some deep learning algorithm is working, and that learns the, that analyzes the sentences, whether the people are talking about good or the bad, and they can, segment, let's say this much of the people, they are giving maybe 4 rating or less than 4 rating or 3 rating or maybe 5 rating like that. So the companies might be companies will know, okay, what the people are talking about with, with them, and then they can find out some specific keywords which are widely used. Those may be sometimes abusive words the people they use, or sometimes the very negative words or the positive words they can segregate. So let's say this is the frequency of the positive words: good, very good, excellent, like this. And this is the frequency of the negative words, maybe bad, worse, worst, don't buy, don't go, fake, yes, waste of money, like this. So this kind of segregation we can do with the help of natural language processing. Nowadays, many advanced tools are there. They work upon the NLP and they can write the text or the content for you. We have to just tell the topic name and the size of the content we want, and they will be writing on its own. Speech recognition. So many tools are there which, when we talk to any chatbot, so we are saying yes or no, and that can understand. If I am saying yes, then it will behave in a different way. It will respond in a different way. If I am saying no, it will respond in a different way. So whatever you're saying, I'm looking for this, I'm looking for that, and the chatbot will reply. So they work upon the technology, we call it as the speech recognition. So again, deep learning neural networks is working internally that can analyze the tone and the pitch and everything from the speech and the words that is being said, and accordingly they will generate a response. Recommendation system, it is the example of deep learning. Now, nowadays, as I told you, YouTube was one of the examples. Nowadays, what happens, let's say we are going to any online shopping portal, for example, Amazon. We type some product and we stay there for 5 minutes and then we close it. And then what we see next day onwards, we start getting ads related to that product in our browser, on our Instagram, or on our Facebook. So deep learning algorithm, that is recommending those, products to us from different companies, whether we might be interested in this or that. So recommendation system we call. Um, if you talk about the Facebook, Facebook suggestions. So Facebook suggestions, they are recommending like these are the people you might be interested in knowing, or they might be anyhow related to you. Instagram, feeds or reels that we so according to our taste, they keep on recommending us, or they keep on showing us the reels related to our interest, so that we can stick to Instagram more and they can earn more money like this. So this is the exam. These are the examples of the recommendation systems. Industrial automation. Nowadays, a lot of things in the industry, especially in manufacturing, can be taken care by the automated systems, or we can say the robots. Up to some extent, they can work on their own with limited human intervention. So we can train, or you can say the robotics can be one of the examples of that. We can train such automated systems with the help of deep learning algorithms. So that is all that I have, this small idea I wanted to give. I hope we are getting some idea related to this. So what is artificial intelligence again? When we impart some knowledge to a machine, we call it as the artificial intelligence. How it works? The subset of artificial intelligence is machine learning. In machine learning, what we do, we have some mathematical or statistical function to which we feed the data. Once we feed the data, it starts learning the pattern from that data, and on the basis of that, we train that algorithm. And once the training is complete, this that algorithm starts telling us, or it starts behaving according to the feed that we have given to that algorithm. So if we have the complex problem that we cannot create any mathematical function about, then we can solve it using the deep learning algorithms. Deep learning algorithms are nothing but they work on the neural networks, which are the replica of human brain. So they can identify the complex relationships from the data, and on the basis of that, they can make decisions. But one thing that is common in all these things, whether we talk about the artificial intelligence, whether we talk about the machine learning or deep learning, Data is the basis. We feed the data. On the basis of that data, the learning is there, and according to the learning, the result or the recommendation or the prediction is there. So data, the refined data we have, the more, the better results we are going to get. So if we are talking about artificial intelligence or machine learning or deep learning, we have to sharpen our skills on the understanding of data first. And to understand the data better, we should be thorough with the statistical concepts. So that is all from my side. Thank you so much, and I wish you all very best of luck.